The chapter for revision is atoms. As we all know, atoms are the smallest particle of matter. The first scientist who explained the structure of atom was J.J. Thomson, where he explained it as plum pudding model, watermelon model, and this structure or the explanation was not enough to explain the atomic structure. So the next scientist came, Rutherford. You can remember, as he is so rich that he came in Ford car and he did the experiment in gold foil. So there are four names in which this under which the Rutherford experiment is known. The first one we call it as Rutherford experiment itself. Second one, as it was done on gold foil, it is called as gold foil experiment. And this experiment was first done by Giger and Martson. Therefore, it is also known as Giger-Martson experiment. And since alpha particles were used for the scattering experiment, it is also known as alpha scattering experiment. So four names are given for the Rutherford experiment, and the experimental setup was he took thin gold foil and he passed alpha radiations through it. Alpha radiations were passed through it. Why did he select gold foil? Because gold is the most malleable metal. And he placed a screen and he passed alpha radiation through it. It was seen that majority of the alpha radiation passed through the gold foil without any deflection, indicating that majority of the space in an atom is empty. Then again, it was seen that some of the alpha radiations got deflected from the center. So, alpha is positively charged. In order to deflect a positive charge, there should be a positive charge at the center, and he named this as nucleus. So, Rutherford was the scientist who discovered nucleus, and he said that majority of the space in an atom is empty. So when we are finding the velocity vector, the distance of the velocity vector which makes from the center of the nucleus, we call it as the impact parameter B. It is seen that when the impact parameter is less than that means the ray is very close to the nucleus and hence it will be scattered more. So when impact parameter is less, the scattering will be more. And when the impact parameter is more, that means the ray is far away from the center and hence the scattering will be less. So what was the final conclusion of Rutherford atom model was that every atom has a centrally placed nucleus and electrons are revolving around the nucleus. But he couldn't explain the stability of nucleus because, as you know, all the charged particle, when they are moving, it will be radiating energy, and finally the electron will die into the nucleus. It will spiral into the nucleus, and Rutherford failed to explain this. So, who came with the explanation of the stability of nucleus is Niels Bohr. So Niels Bohr came with the three postulates. So he explained the atomic structure with the three postulates. The first postulate being electrons revolve around the nucleus. Electrons revolve around the nucleus, revolve around the in nucleus in fixed stationary orbit. Fixed stationary orbit means as long as it remain in that orbit, electron will neither lose energy nor gain energy. Second is only those orbits are permitted. It's not allowed that everywhere around the nucleus there will be orbits. Only those orbits are permitted whose angular momentum, that is linear momentum times radius, is an integral multiple of h by 2 pi. So only those orbits are allowed whose angular momentum is an integral multiple of h by 2 pi. And we know that when the electron jumps from one energy level to another energy level, then the final energy level minus from where it is coming will release a photon. So if it is moving from lower energy to higher energy, it has to absorb the energy in the form of photon, and if it is jumping from a higher energy level to lower energy level, then it will release a photon, and the energy of a photon will be h nu, or which is equal to hc by lambda. So these are the three postulates of Bohr. So from this we can explain about the structure of an atom, as there will be a centrally placed nucleus and the electron revolve in fixed stationary orbit, and this is my electron, and from the center of that to this is your orbital radius r. So there are two forces which are acting on the revolving electron. One is the electrostatic force, which is equal to 1 by 4 pi epsilon 0 E square divided by R square. And since it is in rotational motion, it will have the centripetal force, which is equal to mv square divided by R. Since it is in equilibrium, we can equate both the forces like mv square divided by r is equal to 1 by 4 pi epsilon 0 e square divided by r square. So it's seen that the r will get cancelled, and you will get an expression for mv square as 1 by 4 pi epsilon 0 e square divided by r. From this, we can calculate the three energies possessed. That is, kinetic energy, as we all know, it is half mv square, which is equal to half into, we know that mv square is 1 by 4 pi epsilon 0 e square divided by r. And your potential energy, as per the second chapter, it is minus 1 by 4 pi epsilon 0 e square divided by r. So your total energy will be equal to kinetic energy plus potential energy, and the common factor is 1 by 4 pi epsilon 0 e square divided by r, and there is a half in the first equation and minus 1 in the second. So half of minus 1 is minus half into 1 by 4 pi epsilon 0 e square divided by r. And you can see that the total energy of the revolving electron is negative. What does this mean? That the electron is bound to the nucleus. It cannot leave the nucleus and go. So when we look into the kinetic energy, potential energy and total energy, we can say that the total energy is always minus of kinetic energy. And what about the potential energy? Potential energy is equal to 2 times total energy, or it is minus 2 times the kinetic energy, because the potential energy should be negative. So this is the first derivation from the chapter atoms. Now the second derivation is how we will derive the Bohr radius. Bohr radius means it is the radius of the first orbit of hydrogen atom. There is only one electron in hydrogen atom. So Bohr radius is the radius of the first orbit of hydrogen atom. So we discuss that the second postulate of Bohr is angular momentum. mvr is equal to nh divided by 2 pi, or r is equal to nh divided by 2 pi into 1 by mv. So we know that except v, all are constants. So in the previous, we know what is the value of mv square is equal to. So from there, I am going to calculate what is v square. So what will be v square? V square will be equal to e square divided by 4 pi epsilon 0 rm. So what will be v? V will be equal to E divided by root of 4 pi epsilon 0 Rm. So when I substitute this in the equation, you get it as N H divided by 2 pi into 1 divided by M into, now your V will be E divided by 4 pi epsilon 0 Rm goes up. So since there is a root, we have to square or take the square on both the sides, so that it will become r square is equal to n square h square divided by 4 pi square into 4 pi epsilon 0 r m divided by m square e square. All the similar terms we can cancel with r, m with one m, 4 pi remaining, a pi will remain. So we have n square, h square, epsilon 0 divided by pi m e square. You can see that all these are constants. And when I substitute the value, I will get the value of r as r is equal to n square times this h square epsilon 0, all the value will give me 5.29 into 10 power minus 11 meter. So when n is equal to 1, that is the first orbit of hydrogen atom, your r will be equal to Bohr radius, and the value of Bohr radius is 5.29 into 10 power minus 11 meter. So always understand that if it in the question they are asking, like if it is based on excited state, what is the radius of second excited state? Means n is equal to 3. But directly if they are giving find the value for n is equal to 4, then you will have to put the n value as 4 itself. I hope that's clear to everyone, and this is the Bohr radius. Now the third derivation of the chapter is energy. Energy of the nth orbit. To define the energy of the nth orbit, what we will do is we will write the expression for the total energy. So we know that total energy of the revolving electron was found to be minus half into 1 by 4 pi epsilon 0 e square divided by r. And you know what is the value of radius. So minus half into 1 by 4 pi epsilon 0 e square divided by n square h square epsilon 0 pi m e square. So 1 pi get cancelled, and the remaining will be equal to minus m e raised to 4 divided by 8 n square epsilon 0 square h square. So it is seen that when we substitute everything apart from your n square, and when you divide by 1.6 into 10 raised minus 19 to convert it into electron volt, you will get this as minus 13.6 divided by n square electron volt. Here also I repeat that when it is given first excited state, if it is given with respect to excited state, then the value of n will be equal to 2. But when it is asked what is the energy of n is equal to 5, then retain the value of n as 5. So it will be 5 square 25. So these are the three major derivations in the chapter. Now coming to the hydrogen spectrum. The hydrogen spectrum means, the value of the n equal to 1, all what is falling to n equal to 1, we call it as the Lyman, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6, and n equal to 7. These are the 5 spectral series which we will be seeing in the hydrogen spectrum. So if all the radiations fall to 1 from all these, if the final point is to 1, we call that series as the Lyman series. Lyman series. And this is the only series which falls to the ultraviolet region, Lyman. So it was the scientist Balmer who studied the spectral series called Balmer series, and he was able to explain, because this was the one which fell in the visible region. So finally, when n is equal to 2, we call it as the Balmer series, and consequently the remaining are all in the IR region. So Lyman falls in the UV region, and we have three more series. I am writing the series once again, like L, BP, BP. You can remember like this: Lyman, Balmer, Passion, Bracket, and Fund. This is when equal to n equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5. And Balmer was the scientist who gave the empirical formula of 1 by lambda is equal to 1 by r into, since it is Balmer, to which series it falls is 2 square minus 1 by n square, where n value is equal to from 1 greater than this, so 3, 4, 5, 6, etc. Now, they will ask you which is the maximum wavelength and the minimum wavelength. So always remember H E is equal to Hc divided by lambda, and your E is inversely proportional to wavelength. So if the wavelength, suppose if you want lambda as minimum wavelength, then delta E should be maximum. So that suppose if they are asking for Balmer, it has to fall from n equal to 2, but your next one should be from infinity. So maximum energy difference means minimum will be the wavelength. But if lambda, it should be maximum, then your delta E should be minimum. So delta E should be minimum, that is should be falling to n equal to 2 from n equal to 3. So this is the spectral. So consequently, we will get all the other spectral series of Lyman, Balmer, Passion, Bracket, and Fund. Passion, Bracket, and Fund all lie in the IR region. So please go through the wavelength series of all the spectral lines as well. Now the last thing is how de Broglie, okay, de Broglie supported the second postulate. De Broglie supported the second postulate. De Broglie supported second postulate. So what is second postulate is 2 pi r, sorry, mvr is equal to nh divided by 2 pi. So what de Broglie's hypothesis says is that lambda is equal to h by p, which is equal to h by mv. So he said that in a circumference of 2 pi r, it can accommodate only n number of lambdas. So for your easiness, how you will draw it is you divide this into 4 and put one wavelength in each of them. Like this is 1, this is 1, this is 1, and this is 1. And now you complete it. This is how the electron gets excited in the 2 pi r radius. So in 2 pi r we have n number of lambdas, or we can write it as 2 pi r is equal to n into h divided by mv. N into h divided by mv. So when we interchange your mv with respect to 2 pi, you will get it as mvr is equal to nh by 2 pi, which is the Bohr's second postulate. And this is the entire content of the chapter atoms.